This is the introduction to radian measure. The definition of a radian is the measure of a central angle so that the length of the intercepted arc equals the length of the radius. There is a good video on YouTube through Khan Academy if you'd like to watch it. It kind of goes through and reminds you what is a degree measure and then converts some of those degree measures into what would it be in radian measure. So if you'd like to check that out, it's about 10 minutes. Here is the website address here for you. So what I have is a picture of a circle down below. And if you think about the circle going around half a revolution, that is 180 degrees. All the way around is 360 degrees. If we think about this in radian measure, the distance around, if my radius is 1 unit, you're going to hear a lot about the radius being 1 unit when we get to unit circle. The circumference around that circle is 2 pi r, radius being 1. So if we go all the way around that circle with a radius of 1, that distance, the angle measure would be 2 pi. So 2 pi and 360 degrees equal each other. This would be what we call in radian measure. This is in degree measure. They are equivalent to each other. If you're looking at going halfway around your circle of a radius of 1, 180 degrees we talked about, as a radian be half 2 pi, so just be pi. So these two angles are equivalent to each other. If you're looking at the initial arc, terminal arc has a radius, and you want to find out what is 1 radian measure, you'll hear some things without the value of pi in it. To find out what is the value of 1 radian, you take 180, remember that's 180 degrees, and divide it by pi, and it's about 57.3 degrees. So the distance from 1 radian is 57.3 degrees. If you want to convert 2 pi to all radians, so you're removing that pi notation. Remember, pi represents 3.14. So if I multiply that by 2, I get 6.28 radians. So if you did not want it in a pi form, the distance all the way around this circle, 2 pi or 6.28 radians. So if this is 1 radian right here, about 57 degrees, or 1 radian. And there are a total of 6.28 radians all the way around this circle. All right, what we're going to focus more on is more what this slide is entailing. I'm going to go through some of the angles and what the quadrants are. You've seen these quadrants before. There are 4 quadrants going in a counterclockwise direction. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. We've talked about some of these angles already. In degree measure, 0 degrees, 90 degrees. Halfway around the circle now is 180. If I go another 90 degrees, I'm at 270 degrees down here. And then all the way back around, 1 revolution around this circle is 360 degrees. If I were to change those angle measures from degree measure to radian measure in the form of pi, here would be 0 radians, how it starts off with. If I go halfway around from here to here, we call this pi. If we go all the way around the circle, we're now at 2 pi. Then we have a couple more let's talk about. Halfway between 0 and pi is pi over 2, halfway. If I want to notice this is pi over 2, 2 pi over 2, 3 pi over 2. Here's 3 pi over 2. If I continue one more pi over 2, this would be 4 pi over 2, sorry, which is 2 pi. These are equivalent. So I converted that 4 separate sections to now 2 pi. All right, so what we're going to do is now sketch some of these angles in radian measure. So I start off with my initial side of 0 radians. And I want to create an angle of theta of pi over 4. If you remember, this is pi over 2. I want to split this first quadrant in half again one more time. So that would be pi over 4. So there's my angle theta. Example B, 3 pi over 4. I'm going to start off with my initial side of 0 radians. Now I'm going to remember, this is all the way across here. From here to here is pi. If I split this up into 4 equal parts, so halfway is pi over 2, or 2 pi over 4. Halfway again is pi over 4. Split this up again, 3 pi over 4. And now let's count. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. 3/4 of our pi. So this is our angle theta. We have our initial side, and then we have our terminal side. And there's how we can create a graph for the angle measure of 3 pi over 4 in radians. A couple more left here, pi over 2. That should be starting to become familiar to you. Here is 0 radians. All the way across is pi, so we split it in half. Halfway is pi over 2. So the angle, initial side of 0, terminal side, here is my angle measure for theta. Notice that it's also 90 degrees. Last one on this slide. 4 pi over 3 is what we want to graph. So I want to split up this pi, this top half of the pi, into thirds. So here's a third, here's a third, here's a third. Then I'm going to go down another piece of the pie, so the bottom half of the circle, so I'm going to split it in thirds. And now I count. 1, 2, 3. So this would be the angle pi over 3, 2 pi over 3, 3 pi over 3, which remember 3 pi over 3 reduces down to pi, and then 4 pi over 3. If we continued on, this would be 5 pi over 3, 6 pi over 3, which reduces to 2 pi. So I'm splitting up whatever the denominator is. So now let's create that angle. So we start off with our initial side of 0, and our terminal side is right down here at 4 pi over 3. So there is our angle for theta. Last two examples, negative 3 pi over 2. We're going in a negative direction. So I look at the denominator. The denominator is 2. So I'm going to split up the fraction in half, that bottom piece in half. So this would be negative pi over 2. This would be negative 2 pi over 2, which also reduces to negative pi. I'm going to go up to the top, split it in half. This would be negative 3 pi over 2, negative 4 pi over 2, which reduces to negative 2. So the angle we're looking for is negative 3 pi over 2. So we start with our initial side. We're going in a negative direction. So this would be negative pi over 2, negative 2 pi over 2, to negative 3 pi over 2. So there's our terminal side. So there's what our angle would look like. Last one, negative 3 radians. This one's a little bit tricky because it doesn't have that pi in it. So if you remember, 1 radian is approximately 57.3 degrees. And I think about all the way around from here to here is 360 degrees or 2 pi. But we're going in a negative direction. So I'm going to start with my initial side. I'm going to a negative direction. I think about this angle, negative pi over 2. Go this direction, now I'm at negative pi. If you remember, negative pi represents approximately negative 3.14. So look at how close that is. Negative 3 radians, and we want negative 3.14 radians. So I'm going to erase this a little bit, and I'm very, very close to that straight across angle. So here is my initial, and go right about there. Now this is just approximate. Maybe I should go a little bit higher than that. And then this is my angle, theta. And that's how you can graph if you didn't have it in pi form. Again, 3 radians would be 3 times 57.3 degrees. As a degree measure, I just check with my calculator here. 171.9 degrees. Very, very close to negative 180 degrees. So negative 71.9 degrees.